online workshop on FTC. It is presented to you by K-12 STEM Education Center at NYU School of Engineering and New York City First. My name is Rishabh, and we have this is our third workshop on FTC, and we've had two other workshops on the previous Wednesdays. I just want to give a quick recap of what we have done in the past two Wednesdays. And on the first Wednesday, we looked at the basics of robotics. We looked at the basic anatomy of a robot, the different parts it has. We also looked at certain basic programming in robotc. So robotc is the programming language that we are going to use to program our robots and also to program the robots for the first competition. So next we looked at some certain basic building blocks of a programming language, like the for loop, the while loop, if else statements. So these are the basic building blocks with which you can build complex programs. And we also looked at some configuration of motors and sensors. We looked at what motors and sensors are, which ones can we use for this competition, and we learned how we can configure those motors and sensors with robotc, and we used them in our program. We read certain values with the sensors, and we gave certain values to the motors to actually make the robot do something.
Probably we also have seen how to track the IR beacon.
Yes, so we looked at that in our second workshop. So we saw how we can program a robot to take input values from an IR beacon. So that is an essential part of our challenge this year, because we will be directing our robots to the centerpiece according to the IR beacon values that we read. And so that was week 2, and now here we are in week 3. Today we will be looking at certain controllers that we can use along with a robot. So we are going to see how we can program things like servos and DC motors. So Raghu, can you just tell everyone why we are going to be using DC motors and servos, and what are these complex sounding things? I mean, why do we need to use them? We already have motors in our kit, and we can use the same kit, but why are we going to be learning about this today? So we will be looking at certain controllers that we can use along with a robot. So we are going to see how we can program things like servos and sorry about that. So
so the thing is that Rishabh, once you start building with the Tetrix part, what we have here. So this is the basic structure built out of the Tetrix part. Tetrix parts which we have, and these parts are officially supported. You can use these parts officially in the FTC, and these things come along with the kit which you get once you register online. And so this thing has all the FTC Tetrix part, which are metal parts, right? But till now, what the kind of motors which you have seen are like the small ones, which don't have the higher amount of torque to drive a robot heavy like this. Because if you look at the battery itself, is like really heavy. The battery which we use for FTC. So that is one thing to get higher torque. And one more interesting thing is that not only just the DC motors also have high technique servo motors, which can be used to build joints. Let us say you want to go there and you want to
pick up something,
or you want to pick up the balls,
right?
And put them to do this kind of movements, like you want to drag it up, then drop it in the tower.
Right.
To do that kind of stuff, to build complex motions like that, and every joint, let us imagine my hand like part with how many joints? 2 joints.
Right.
Let us also assume this one more joint. So let us assume a servo motor at each of this joint.
Okay.
So you can build some complex movements like this.
Okay.
And that's it. But the thing is that people should get to know that your programs will become complex as you start using the external hardware.
Right.
Non-Lego hardware, I can say that. So once you start using them, we'll be seeing how to use the Tetrix DC high technic DC motor controllers, high technic servo motor controllers. So probably we are going to see all these things in today's workshop, right?
Okay, so as I understand from what you say is that the basic mechanism is going to be the same, but all we are doing right now is programming for external controllers which are high torque and have a higher amount
precisions.
of precision and energy. Okay, so we are going to be looking at these things today, and I would like to remind everyone that this live stream is being broadcasted on Google Hangouts, and our Gmail address is centerfork12stem@gmail.com. And so let's begin with our today. All right. Okay, so this is how a controller looks like. So basically what this does is it takes certain power from the battery that we have, and that power is going to be supplied to these controllers. Now these controllers are actually not going to you know, initiate any movement. They're just going to be passing signals to our motors, which will be connected to these controllers. So we have two types of controllers over here. We have a DC motor controller and a servo controller. So a servo controller is sort of a motor which has high precision in terms of the rotation that it can perform. So we have a rotation that can go from 0 to 180 degrees, and we can control that rotation degree by degree, so to say, using our program. To say move only from 0 to 30 degrees, you could not do that earlier with the motors that came along with the Lego kit, but now you can actually perform those precision movements along with a servo controller. So we are going to be using the servo controller for our servo motor, and also we will be using a DC motor controller, which will be motor for which will be used by a motor of high torque, and so we are going to look at how we can make the connections to our robot along with these controllers and the motors that we have.
Yes, Rishabh. So, Rishabh, as you were talking about the Lego motors, so you mean to say that these motors are more intelligent than Lego motors? Like you can ask him to go, you can ask the motor to rotate 30 degrees.
Right.
So probably can we do the same thing with the Lego motors with some extra motor programming using encoders?
Yes, we can do that. We can certainly do that because we learned about how even a motor in a Lego kit can be programmed according to certain degrees using encoders. We can certainly do that, but going to precision, and it is going to give you more torque to move the parts which are heavy duty that come along with the Tetrix kit. So we will have to be using those motors along the high torque motors along with our robot. So these are the controllers that are going to help us to do that. So let's move ahead. All right. So this is a very basic schematic diagram of how the connection is going to look like. So we have the brick on the top left corner, and the brick has two connections going out of it. First connection is a touch sensor that we have already seen in our previous workshops, and the second connection is going to a DC motor controller. Now this DC motor controller obviously has to be powered, so a motor connected to this DC controller. So in a cream color we have the DC motor, which is also connected to the DC motor controller. So we obviously need to power this controller, and that is why we connect a battery to it. Now this battery is a high power battery. It's a 3000 milliampere hour battery, and we connect a small switch to it so as to turn the power on or off. So what this basically is doing is turning the power on or off for our controller along with the use of a switch. So that's a very simple circuit out there where we can see that the switch is between the red wire. The red wire, the connection is complete if we turn the switch on, and the connection will be broken if the switch is turned off. So basically what we are doing is we are giving the power from the battery to one DC motor controller. Now along with that we have one more servo controller which is connected to the first DC motor controller. Now that connection is being made with black and red wires, as you can see, which is going to power the second controller. And so what we do is we do not directly connect the battery to the second controller. We connect the battery only to the first controller, and from the first controller we give the power to the second controller. So that's a very simple connection to understand. Also on we can see that there are black wires being connected to the brick. Now these are necessary obviously because ultimately we are going to give the output from the bricks, and the bricks have to be controlling those servo controllers or DC motor controllers. So on the second controller we can see that there is a servo connected to it. Now this servo is the motor that we were talking about, which can rotate from 0 to 180 degrees, and every degree can be controlled via our robot C program.
So Rishabh, is it that always I need to control a DC motor controller with a servo motor controller, or can I also directly connect it to the brick? Can we also connect it directly to the brick?
Yes, obviously you can connect it to the brick. The connection with the So this connection is called a daisy chain, a concept that we will talk about more in detail.
So by doing this, you can say that we'll be saving the sensor ports.
Yes, obviously we are going to be doing that. We are going to be saving the sensor ports. Now we have, if we connected the servo controller directly to the brick, we would have wasted one more, output from our brick. Okay. So instead of doing that, we can daisy chain even the control instructions by connecting the thick black wire from the DC motor controller to the servo controller. We can obviously not, choose not to do that. We can connect it directly to the brick, but this is also a fairly all right. Next, this is the servo motor that to a controller. It is a Tetrix part, and we can see that the values, the values in the degree go from 0 to 180 degrees. So it is fairly possible to make a rotation of half a circle, and the actual values for these degree values are from 0 to 256. So the half of that, which is 127, directly corresponds to 90 degrees. So we can see that 90 degrees is being signified by the value of 127, which we are going to give to the motor through our program, and a maximum value of 256, which will signify that the motor rotates from 0 to 180 degrees. All right, so this is the concept of a daisy chain. So as we have controllers, now these controllers can be mixed and matched with any type we want. We can have servo controllers in place of these, or we can have all of them as DC motor controllers, or however we would like. So the basic concept here is that instead of wasting ports from our brick to the controllers, we can directly give the input from one controller to the second, to the third, to the fourth, which actually kind of forms a chain. So hence the word daisy chain. Mm-hmm. And the same thing can be done for the power. So a power connection has to be made only to the first controller, and we can daisy chain the power to the second, third, and the fourth controllers. So that's the basic concept of servo controllers, DC motor controllers, and DC motors and servo motors. So we are going to jump right into programming these things for ourselves. So the basic steps to configure these controllers is the same. We hit robot, we select the platform type to Lego NXT plus Tetrix. So now we understand why there was a plus Tetrix, and now we need to configure the controllers. We can first write the task main and have it ready to put in the values for our controllers and the motors. Now let's go to motors and sensors setup. Let's go to external controllers, select custom over there, and then go to Tetrix motor controllers. So that is select the first controller. Then we can select a servo controller and hit apply. Next, we need to go to the motors connection. So we go to motors and sensors. We go to servos. We select the servos that we have. So these are all the we can give them names over here, and we can select the type of servos. We can either have a standard servo or a continuous rotation servo. So we're going to go with the basic configuration over here. And so let's write first line. We start with the while loop and make it always true. So this is going to run forever. We select the servo and select the first servo, give it a value of 0. We wait for 2 seconds. Then we select the next servo. So this is going to make servo 1 rotate to 127, which actually corresponds to 90 degrees. We make that happen for about 2 seconds, and then we make it rotate to 180 degrees, which corresponds to the value of 256. So we can compile and run the program. So there was an error because we did not turn on the brake. We can turn on the brake now. Get rid of it. Okay. Now we can start the program. Okay. We can run that again. Alright, so here we can see that it starts with the value of 0. So it is at 0 degrees. Then we perform that for 2 seconds. We go to 90 degrees, signified by the value 127. We wait for 2 seconds again, and we go to 180 degrees, signified by the value 256. So that's a servo motor controlled by a servo controller. That's a fairly simple and a basic program that we have written in Robot C to control the servos. So as Raghu mentioned earlier, we can use the servo motor to actuate our joints. So when we want to lift a bunch of balls and leave them in the centerpiece, we can do this using the servo motor. And what this gives, so if we want to perform this only till a certain angle, we can give the corresponding value from 0 to 256 and control the robot in a very precise manner. Next, we are going to again look at some program that will control the motors, the DC motors. So let's do that.
So Rishabh, how are you going to control the DC motor?
Okay, so the DC motor is going to be controlled in a similar manner like a servo controller. So we need to configure the DC motors in the same way that we controlled the servo controllers and the servo motors. So we go to robot and we configure our DC motors.
Mhm. First, should I start off with?
Okay, so we already have a motor configured. What we can do is include a joystick driver over here so that we can control the motors with the joystick. And now we can write the program to control the motors along with the joystick. So let's do that. Okay, we got rid of everything. Now we can get rid of that too. All right. So very important thing to know is the line get joystick settings joystick. That is going to give our program all the settings of the joystick, and we will be able to use our joystick in our program. And let's write an if case. And say give it a condition. So we basically give it this condition: joystick.joy12 is greater than a certain value. Let's go on 20. And we're going to go on with our motor programming the same way that we did in previous workshops. We're going to give it a value of 20. So the motor D is going to rotate with a value of 20 or a speed of 20. We can do the same thing for controlling another motor. We also need to give it an else condition. Okay. So let's try to understand this code for ourselves. First, we have an if condition, which is going to check the value on joystick 1 and the value of y2 on that. If it is greater than 20, then we move motor D by a speed of 20. Else, if the value is less than 20, so I think there's a typo over there. If it is less than 20, we rotate it backwards.
Yeah.
With a speed of 20, and otherwise we just make the motor stop. We can do the same thing for another motor, just copy and paste that, and we can check the same thing for a value of y1. That is greater than 20, we move motor E by 20, else if that is less than 20, we move it by minus 20, which is going to make it go in the reverse order, or else we make it stop. So there we have it, a basic program, and now we're going to switch and see if we can control our robot along with our joystick and move the motors the same way we did for the basic motors. All right. Have this here. And
so Rishabh, can you explain the code once more?
All right. So yeah, surely we can do that. So we first start with the basic configuration of the motors and the servos. So we go to robot, we go to motors and sensor setup, we select the external controller, we configure the controllers, then we go to the motors and servo setup, we configure them, and we have a bunch of lines automatically included to our program. Then we import the joystick settings. So first we need to include the drivers for it. So we write line include joystick driver.c, and then we get the joystick settings. So we say get joystick settings joystick. Then we start with a while loop, and in the while loop we always make it true, and then uh, we write an if case for reading the value of joystick 1 and the value of y2 in that. If that is more than 20, we make the motor D rotate by 20. If that is less than 20, we make the motor D rotate backwards with the speed of 20, or else we stop rotating. We copy and pasted the same code to control motor E. So we check the value of y1 on joystick 1. If that is more than 20, we move motor E by 20. Else, if that is less than 20, then we make it go backwards with a speed of 20, or else we stop it. So that was the basic code. It's very simple. It's not very complex, and surprisingly, this is going to help us control the entire robot using external motors and a joystick. All right. So let's look at the robot now. Okay. So let's compile and download the program. Okay. And we can get the joystick controls and the so we have the joystick control settings. We can see the values over here, and we need to select tele-op and tele-op running. If we hit ready, then it is going to wait for a start, and if we select the option tele-op running,
Rishabh, can you explain us this thing? In the starting, it showed waiting for start, right?
Right. So that is basically going to be useful when we are on the field. So we need to have the joystick being controlled by the FCS. So until run their controls, and for our we need to check tele-op ready. So that basically means that we're not going to be waiting for any start signal over here, and we can start the program. So let's have the joystick in our hands and see how we can control this robot.
So right now the robot is waiting to start, right?
Yes.
So how do I give the start command manually?
So you can just select, and that is just going to start the program.
So first I hit tele-op ready,
yes.
Then tele-op running, right?
Yes.
So now the tele-op is running, right?
Right. So now we can basically control our robot. All right, so we have our joystick over here, and we can basically control our robot. So when I control the right motor with my joystick, it goes back. I can make it go ahead. If I pull back both the joysticks, then obviously the robot goes backwards, and if I push it, the robot is able to go forwards. So I can easily control the robot using the joystick, and we saw that the program was fairly simple. The connections are fairly simple over here. There's just a battery going from one servo controller, and we are daisy chaining that, the second servo, motor controller. And similarly, we have the
Rishabh, can you show us the exactly how the wiring is done? Can we have a look at that?
All right, sure. So let's have a look at the wiring very specifically. Okay, so we can have a starting point for our connections over here. We have two external controllers. We have the brake, and we have a battery. So these are the four components that we have connected. And obviously we have the DC motors connected at the bottom. So the DC motors are going to be connected to the DC controller. So we have the DC controller over here. We have a servo over here. Sorry, it's actually the other way around. This is a DC controller, and this is a servo controller. So we can see that we have the servo motor connected to the servo controller. So this is a very simple connection where we connect it to channel 1. So we have channels 1 to 6. So we can connect up to 6 servo motors on a servo controller. So we have the first channel connected to this servo motor over here. And we're going to be having two possible motor connections to our external motor controller, DC motor controller. So we have the two wheels and their motors connected to this external DC motor controller. So that's a very simple connection. And now we need to see how we get both of these controllers powered. So we have the battery over here. The battery is directly connected to the DC motor controller, and we have a switch over here. So if I can turn this, so we have the switch over here. So the switch is basically a circuit breaker that we have over here. So that is going to connect or break the circuit for us, and we have the batteries connected to the battery ports on the DC motor controller, and we daisy chain the same power that we get from the DC motor controller to the servo motor controller. So we have the servo motor controller and its power ports connected directly to the power ports of the DC motor controller. So that is powering the external controllers. It's very simple. It runs from the battery to the first controller, and that's pretty simple. So now we have to see the connections coming from the brick. So we have one wire running from the external port of the brick to the controller. So we have the controller connected over here, and on this configuration right now we have both the bricks connected individually to the external motor controllers. But we can very well get this port out from here and connect it to the servo control over here. So this is a very valid connection. We can certainly do this, but for this configuration, simply connect it to the brick.
So here we are using both the sensor ports then?
Yes, so here we are using both the sensor ports. As we discussed earlier, we can obviously daisy chain it, but here it's a very simple configuration. So those were the connections. We saw how we could program very easily for our controllers using Robot C and all the widgets that we have, and that's all we have for today. And we're going to wrap this up over here, today's workshop. And please email us any questions if you have. We would respond to them via email. The email is k12stem@gmail.com. Follow us on Facebook and Twitter. And we will be having our next and final workshop on the 10th of December, which is again a Wednesday at 4 p.m. So we'll sign off now, and we'll see you in the next workshop.
Thank you, everyone.